In this video, we will be discussing about arcs and central angles. Our objectives are: number 1, identify the different geometric relationships between arcs and central angles. And number 2, solve for the measure of central angles and their intercepted arcs. Let us first have a short drill. Determine whether the given measure of the arc of the central angle is either minor, major, or neither. For the first item, the measure of the arc PIR is what? Is it minor? Is it major? Or neither? Second item, the measure of the arc BC. Is that a minor, major, or neither? And last item is the measure of arc ME. Is that minor, major, or neither? So let us check if you got the correct answer. For the first item, it is a major arc. This PIR is a major arc since it measures more than the semicircle or more than 180 degree. For the second item, this is a minor arc since it measures less than 180 degrees. And the last item is neither since it is not minor or major arc. Arcs and central angles. Definitions. A central angle of a circle is an angle whose vertex is the center of the circle and the sides are radii of the circle. Here, the vertex is the center of the circle O, and its sides are OA and OB, which are the radii of the circle O. That is what we meant by central angle. Congruent arcs. Two arcs are congruent if they belong to the same circle or to congruent circles and have the same measure. So in this illustration, the two arcs here are both 45 degrees. Then they have the same measures. This implies that they are congruent arcs. Theorems and postulates on arcs and central angles. The first one is the central angle intercepted arc postulate. The degree measure of a central angle is equal to the degree measure of its intercepted arcs. For example, if the value of angle BOC here is 45, then this arc BC is also 45. That is what we meant by central angle intercepted arc postulate. Second, the degree measure of a major arc is equal to 360 degree minus the measure of the minor arc or central angle. In this example, if the measure of the arc BC or the minor arc is 45 degrees, then we will get the major arc BMC by just subtracting the minor arc or the 45 from the 360 or the whole circle, and we will have 315. Next, a semicircle is always equal to half of the circle's circumference. For example, the measure of the arc MAE is equal to 180. Here likewise, the measure of angle ME, it is also 180 degrees. Next, sum of the measures of the central angle. The sum of the measures of the central angles of a circle with no common interior points is 360 degrees. Take note here the word no common interior points, meaning interior points of that angles are distinct. For instance, here, if you add up this angle 1, 2, and 3, and this angle 1, 2, and 3 has no common interior points, then it will result to 360 degrees. Congruent circles. Circles are congruent if their radii are congruent. For example, if the radii of circle A is 6 cm and the radii of the circle O is 6 cm, then these two circles are congruent circles. Minor arcs, chords, congruency theorem. In a circle or congruent circle, if two minor arcs are congruent, then the chords subtended by the arcs are congruent. Note that the converse is also true. So let us have this illustration. So if this arc AP is congruent to this arc AM, then this chord AP is congruent to chord AM. So the converse is also true. So the converse of this theorem is that in a circle or congruent circle, if the chords subtended by the arcs are congruent, then the two minor arcs are congruent. So here, if this chords PA is congruent to this chord AM, then this arc AP is congruent to arc AM. So for instance, if this arc AP and arc AM are both 45 degrees, then these two chords are also has the same measure or also congruent. Likewise, it's converse. So if this chord subtended by this chord subtended by this arc are congruent or has the same measure, then this arc AP and this arc AM are also congruent. Central angle minor arc congruency theorem. In a circle or congruent circle, if two central angles are congruent, then their corresponding minor arcs are congruent. Note again that the converse is also true. So let us have this illustration. If angle PSA here is congruent to angle ISR, and if angle PSA intercepts PA, as we can see in this illustration, and ISR intercept arc IR, then these two minor arcs PA and IR are congruent. So its converse is that in a circle or congruent circle, if the two minor arcs PA and IR are congruent, then its corresponding central angles are also congruent. So here, if arc PA is congruent to arc IR, angle PSA is congruent to angle ISR. So for instance, if this angle PSA has a measure of 35, which is same with ISR, also 35, then arc PA is congruent to arc IR. So its converse is that if this arc PA and arc IR are congruent, then their corresponding central angle PSA and ISR are also congruent. Central angle chord congruency theorem. In a circle or congruent circle, if two central angles are congruent, then their corresponding chords are congruent. Note that the converse is also true. So here, for example, if angle AER is congruent to angle IED, then chord AR here is congruent to chord ID. There is also a note here that the converse of this theorem is also true. So the converse of this theorem is, in a circle or congruent circle, if their chords are congruent, then their corresponding central angles are congruent. So here, if this chord AR is congruent to this chord ID, then their corresponding central angles IER is congruent to central angle IED. So for instance, if the central angle measures 35 degrees and IED also measures 35 degrees, then their corresponding chords are congruent. So its converse is just the other way around. So if these chords AR and ID are congruent, or for example has both 10 centimeter long, then their corresponding central angles AER and IED are also congruent. So since you already know the different theorems and postulates about arcs and central angles, let us try this example. If LP here is 2x plus 11 and MN is 3x minus 8, what is the measure of LP and MN? So LP here is just equal to MN. So we are just going to equate 2x plus 11 is equal to 3x minus 8. So that's 3x minus 2x is equal to 11 plus 8. So our x here is 19. So in finding the measure of this LP and MN, we are going to use either this 2x plus 11 or 3x minus 8. In this case, we use 2x plus 11. So substitute the value here of x. That's 2 times 19 plus 11, 49 units. So the reason here is that if two central angles are congruent, then their corresponding chords are congruent. So as you can see here, this central angle LOP and MON here are congruent. Therefore, these corresponding chords are also congruent. Another example, in the figure, line sub 1 is parallel to line sub 2, and PR and QS are diameters of the circle O. If angle POQ is equal to 118 degrees, find the following. Number 1, find the measure of angle POS. So the measure of angle SOQ is equal to 180 degrees since this SOQ here is a semicircle and the semicircle measures 180 degrees. Measure angle SOQ is equal to the measure of angle POS plus the measure of angle POQ. Reason: linear pair theorem. Since these two angles POS and POQ form a linear pair, thus these two are supplementary, meaning their measures add up to 180 degrees. So by substitution, the measure of angle SOQ is 180 degree is equal to the measure of angle POS plus the measure of angle POQ, which is 118 degrees. And subtract this 118 from 180 degrees, then the value or the measure of angle POS is equal to 62 degrees by addition property of equality. For the number 2, find the measure of this arc QR. So the measure of angle POS is equal to 62 degrees. Reason: linear pair postulate. It is because POQ and POS are supplementary. Then if POQ as given is 118, then angle POS here is 62. Next, the measure of angle POS is equal to the measure of angle QOR, which is equal to 62. It is because these two angles are vertical angles, and vertical angles have equal measures. Next, the measure of angle QOR is equal to this arc QR. It is because the degree measure of a central angle is equal to the degree measure of its intercepted arc. The central angle QOR is just equal to this arc QR. So therefore, by substitution, the measure of arc QR is equal to 62 degrees. And last, if PQ is equal to 6x plus 5 and this SR is equal to 11x minus 5, find the value of x. So here, angle POQ is equal to angle SOR. It is because they are vertical angles, thus they have the same measure. Next, we're just going to equate 6x plus 5 is equal to 11x minus 5. It is because these two chords are just congruent. Reason: if two central angles are congruent, then their corresponding chords are congruent. Since angle POQ are congruent to angle SOR, then their corresponding chords PQ is just congruent to this SR. So here, 11x minus 6x, that is 5x. And 5 plus 5, that's 10, by addition property of equality, and then divide both sides by 5, then our x here is equal to 2 by multiplication property of equality. So since you already know the different theorems and postulates on arcs and central angles, you are now ready to answer Activity 7, What's my degree? Activity 8, Central angles -1. Activity 9, Central angles -2 on pages 19 to 20 of your learning package 5.